I'm Dick Malloy with ReGen Power Systems. We're a company located near Orange, Massachusetts, and we're developing a technology that will utilize lower temperature heat to make electricity. The technology is fairly simple. It's a very old technology, actually, and this is an example right here of what's called a Stirling cycle engine. This rotor is being turned solely by the action of the engine inside, which is being in turn driven by the heat in the coffee cup. So there's no battery, there's no flame, there's no fire, and obviously the temperature of that coffee or that water at this point is pretty low relative to ambient air. Our engine will operate in a similar fashion, except we're going to make much bigger engines designed really for industrial use. An example would be a factory like a glass factory. Maybe they make beer bottles. They use very intense heat, 2,500 degrees, to melt the sand and create their glass. Well, the heat that comes off of that oven is still very high. The temperature is very high. But currently, there's really no technology available to utilize that effectively. So our technology will capture the heat in the stack and transfer that heat by means of a heat exchanger to our engine and effectively apply the heat to the bottom side of the engine as you see here, and drive the engine and make electricity. Now, why would we want to do that? Well, there's a lot of energy being wasted here. In fact, somewhere around 50% of all of the energy that goes into this factory to make the glass is currently wasted, thrown away. So there's a huge amount of energy that's available throughout industry, and so it's a very large market, obviously, and it will increase the efficiency of their use of gas. But one of the other benefits, the environmental benefit, is that this electricity will be produced with no combustion, which means there are no emissions associated with it. Whatever emissions may be in this stack have already been produced by the gas that is used to melt the sand and make the glass. So this is electricity with no emissions. Now, typically that electricity would, as I said, be put back into the plant. That means that that plant doesn't have to buy that same amount of power from the utility. That means the utility will not be burning coal or whatever fuel they're burning to produce that electricity. And so it does offset production of electricity that is producing emissions with electricity that produces none. So in addition to the economic benefit, which is that based on the cost of our unit, the factory will probably get its money back in 2 to 3 years, and the unit will last 20 years, so all of the savings that accrue after that second or third year go right in the factory's pocket. But in addition to those economic benefits, there are the environmental benefits to the technology. Now, we also plan to utilize our engine with different sources of heat, for example, solar heat, and we would use some of the solar collector technologies that are available today to bring that heat again to our engine and produce power. We also plan to combine our engine with technology known as gasification, and which is basically a process of getting rid of trash or getting rid of whatever you want to get rid of without the emissions involved in incinerating it. It's a controlled oxygen environment. So we'd gasify, for example, municipal trash, municipal solid waste that currently goes in a landfill, could go into our gasifier, make fuel, and make heat and drive our engine and produce electricity. So there are a lot of opportunities to help the environment, help make a cleaner environment for all of us, really, that are economic at the same time. We're currently in development with our engine. We're making prototypes. This technology is 200 years old, but we had to modify the technology to be able to use it at these larger scales and at these lower temperatures. So we will have protected intellectual property associated with the engine and with the associated technology. We hope eventually to manufacture the engines and sell the engines around the world. We have people contacting us even now from all around the world who are interested in what we're doing because it is different and there is a tremendous need. So we're hard at work at this point to make a 10 kilowatt prototype, which is a relatively small engine, and following that we'll make a 500 kilowatt engine, which is enough to fuel probably 200 homes, something in that order. It's obviously sized for use in the industrial setting. I think that gives a pretty good overview of what we're involved in.